All right, students. So we are going to move on to the next section of this unit. We finished the logic, the language of significance tests. Now we're going to talk about specifically applying them to proportions. And so I need you to have out notes, and I need you to have an Inspire, and you need to have the worksheet that I gave out on the 3rd, Wednesday, April 3rd. We filled out the front of it, but now we are going to actually look at the back of it and get a little bit further into this and talk a little bit more about p-values. But we're particularly interested in proportions today. Okay, so let's go ahead and set up and answer through this worksheet. The first thing that we want to do, let's just read this. It says, nationally, the proportion of red cars on the road is 0.12. A statistically minded fan of the Philadelphia Phillies, whose team color is red, wonders if the Phillies fans are more likely to drive red cars. One day during a home game, he takes a random sample of 210 cars parked at Citizens Bank Park, the Phillies' home field, and counts 35 red cars. Okay. So the first thing we're going to do, we're going to state an appropriate hypothesis for performing the significance test. Be sure to define the parameter of interest. Well, let's go ahead and on here, I'm going to type this. So P is our parameter before we do our hypothesis, or write our hypothesis. So P is the it is the true proportion of Phillies fans with red cars. And so we'll write this out. We have the H sub 0 and the HA. So we have our null and our alternate. We know that our symbol should be P for proportion here. This proportion. And we said that the null is always an equal to, and this is just going to be what the claim already was. The nationally, the proportion is 0.12. Okay. And what this fan is curious about is if he wonders if Philly fans are more likely to drive red cars. So that is making me think that this should be a greater than. So we're going to put greater than 0.12. Okay. And so we've done part A. We stated the hypotheses, which are what I've written in red on here. And then we have defined that parameter of interest, what we're looking for. So part B says that the p-value, which we are going to calculate this ourselves, the p-value is 0.0187. We want to interpret this p-value in context. So we're going to repeat our definition from yesterday, which we wrote about here. We said a p-value is the probability, assuming that the null is true, that the statistic would take on a value as extreme or more extreme than the one actually observed. Well, I'm interested. What did we actually observe? What did he get? He got 35 out of the 210 red cars. Let's write that. So p hat is equal to 35 out of 210. Let's calculate what that actually is. So 35 divided by 210. So that is 0.16 repeating for that. Okay, so that's the proportion. Now that is in fact larger than this. And so we're looking at this value here. We can see that basically what this is saying is this sample is unlikely to happen by chance. This is a low p-value. Okay, this is a low p-value. So we'll talk about that in a second. So let's write what this means. So 0.0187 is the probability of getting a sample proportion of 0.16. We'll just go 167. Assuming that the population proportion is 0.12. So what conclusion would we make? Well, it doesn't seem like it would happen randomly. It seems like Phillies fans are more likely. Okay. Now in our notes, we had written about something called alpha level. Remember, if the p-value is low, reject the hoe. Okay. If the p-value is lower than alpha, then the results are statistically significant. So back in your notebooks, let's actually add something to this bullet point here. Alpha, we're going to say this, alpha is typically 0.05 less otherwise stated. There we go. So that's important. And so we're actually going to use that rule right now in this problem. So we're going to actually say that we're going to say alpha equals 0.05. And we're going to go ahead and write up our conclusion. I'm going to do that now. Okay, so we're going to say this. Since the p-value of 0.0187 is less than, I need alpha, so we're going to write alpha equals 0.05. We reject the null hypothesis. So that's the first, like that's what the conclusion would start with. But then we also have to state what there's evidence for, which we found evidence that the alternate is true, and we're going to write that in context. So we're going to say this: there is convincing evidence that the true proportion of red cars owned by Phillies fans is greater than 0.12. And so that's how you write up a conclusion for a hypothesis test. And what we're going to study today, we're obviously going to be talking about how to write a conclusion, but we're also going to look at the full process of significance tests for proportions, and we'll look at some examples to practice with, some more examples. So let's go ahead and go back to our notes, and we'll pick up from where we left off here. But I'm going to start a new page. Okay. So we're gonna say writing conclusions, because we talked about this conclusions, and we said there's two options. You're going to either reject or fail to reject. But what we're going to do is we're going to put a template here for you guys. This is sort of your go-to, and we kind of had this with the confidence intervals. So you guys took that test yesterday. We had the interpretation of confidence intervals. But this is going to be very similar. So here we go. So because the p-value of blank in here, by the way, you're going to put the p-value. Let me write it like that. We'll underline it. So is, and in this next part, less than or greater than our significance level alpha and then we'll put At your significance level. Okay. Normally it's 0.05, like we said. The reject or fail, reject. Zero. Okay. Okay. So that's the first part, and that looks a lot like what we wrote here. Since the p-value is less than alpha 0.05, we reject HI. That's what we came to the conclusion of on our worksheet. Okay. And we say there is, here we say convincing or not convincing evidence that the true, and then we put parameter in context with J. Yeah. So that's exactly how you would want to interpret this. And so in your My Open Math, I think we had looked at one of those examples here. So they have it written in similar formats to that on here with these conclusions, but generally this captures the general idea of all conclusions that you could write. So I want to discuss how to run a significance test for proportions. So what you can do, let's draw a line in our notes. Taking so long. So running significance tests for proportions. Okay. We'll also need our inspires for this, because this is how we're going to show how they got that p-value on the other sheet. Okay, so always when you're running these significance tests, you want to state hypotheses. Let's just sort of break this into steps. So one, we state hypotheses, significance levels, alpha, by the way, and define the parameter. This is exactly what we did today when we started with this. Stated the appropriate hypothesis and defined our parameter of interest. We didn't state alpha. They didn't want us to on this problem, but we did that down here. So I could move that up here to be technically correct to what needed to happen. So that was kind of step one. Okay. Step two, choose the correct inference method. This step two kind of has two parts to it. Okay. Okay, so we'll kind of break it down like that. So 2 parts: choose the correct inference method, and then we have to check the conditions. Okay, check the conditions. So for proportions, is a, this is a 1 prop Z test is what it is. Let's actually grab our inspires now and look at where this is all going to happen. Okay. So if you have your Inspire, we're going to press Menu. Go to Statistics. Last chapter we were on confidence intervals, but this time we're going to be in stat tests, and we're going to be using this fifth one here, one prop z-test, right here, one prop z-test. So you can go ahead and click that, and we'll talk about all this in a moment. But we can't really use this unless we have checked all of these conditions. The first one is it a simple random sample. The second one is we check the 10% rule. We've talked about all these every chapter. And then the third one is it normal, the large counts. Remember, we used that. That's what I was trying to do here with this one for Miss Gallus example. I'm going to actually copy all this down. Here. To move this down. So those are the three conditions that we have to check. The normality is very important. If none of this works, if it's not normal, because essentially we're doing a normal CDF to find for our third step, which is calculate p-value. Okay, and this is actually a pretty easy step for this. They did it for us in this example here, 0.0187. They did it for us, but I want to see how they got that. Okay, and the Inspire is the way that we're going to get this. Okay, so in here, this P0 part is the proportion from the null hypothesis. Oops. That's the proportion from the null hypothesis, which they said that it was 0.12. That is what is known to have been the case with the Phillies. Okay. Just red cars on the road. Okay. So then he surveyed. How many people did he survey? He surveyed 210. So that goes here for N, and 35 had red cars. Now this alternate hypothesis, you're just going to pick the correct tail of the test. So it's either going to be greater than, not equal to, or less than. He thought that the Phillies fans would be greater than, so we put greater than, we hit OK. And you can see right here, this is exactly where they got that 0.0187. So there's our p-value right there. Okay. So in here, we're going to say use technology. Okay. And we can write this Inspire. It is menu, statistics, stat tests, one prop test. Okay. And then you draw a conclusion based on, and that's exactly what we wrote about here. Okay. So everything that we've already done, all of this as we started class today, they had just already calculated the p-value for us on this sheet, but now we know how to do that. That was the only thing we were really missing. So now I think we're ready to actually try a question in the MyOpenMath. And so that's what we're going to do. And once we finish that, I'll probably pretty much be done for the day. And you guys can just work and make sure that you're caught up on your MyOpenMath. Okay, so we're going to look at question 28 on here. And this pretty much always, like these questions here are built so that you verify all of these conditions beforehand. I'm just going to start with this part here, since it's technically our first step is setting up the hypotheses. So let's do that. So the proportion of people that own cats is 70%. I'm sure your question is a little different. A veterinarian believes that this proportion is larger than 70% and surveys 700 people. Test the veterinarian's claim at alpha 0.005 significance level. So you can see here the problem's giving us our significance level. He thinks it's larger than 70%. So we go down here and we look and we have to make sure we pick the correct one. Well, first off, we don't see the word mean anywhere. We see percentage. We know it should be proportion. So it's not going to be either of these two here. It can't be means. Okay. Next, we kind of have, it also can't be this one. Okay. So what we're really looking for, we said it could be any of these symbols with the equal sign at the top. We're just making sure it's not like a less than or a greater than. But we really need to look at which direction the alternate is, because he said he wants it to be larger than 70%. And so that leads me to think that this one is the best one, which it is in fact. Don't get too caught up on the null hypothesis there with that less than or equal to. Just treat it as if it's equal to. Okay. All right. Up here, if we're following our steps, we state the hypothesis. We have our significance level, which I misspelled that. It's not. We define the parameter. I don't know if this problem's having us do that. Oh, I guess I got to relog in. Okay, so we're back. So, yes, this. Okay, so we didn't really. P is the proportion of people who own cats. So we're not writing that down or anything, but that is what that's what that would be. Next, choose the correct inference method. We are going to be, since this is proportions, we will be doing a one prop z-test. So we already know that we need to have that ready on the Inspire. So I can go down here, menu, statistics, stat test, one prop z-test. We have that ready. We do need to check our conditions though. By the way, if these fail, we're technically not allowed to do this. Let's go ahead and look at these. So is it safe to assume that the population is less than 5% of all subjects in the population? We have the 10% rule, but this is using something called the 5% rule. So is our sample less than 5% of all subjects? Yeah, this is just people. So we assume that this is less than 5% of all people. So yes, yeah. And then here, this is taking our rule and kind of combining it, the large counts here. It's kind of combining, it's doing n times p times 1 minus p. It's all in one sort of section. A lot of college classes actually have this method, but that's fine. Let's go ahead and do that. So I guess I don't need to have this open yet. So it's 700 times 0.7 times 0.3. So I got 147. It is. Okay. So that is in fact greater than or equal to 10. So that's good. We have our claim. All right. We also have to decide what kind of tail this is. This would be a right-tailed. Based on the sample of 700 people, calculate test statistics. So this is something that we have not talked about, but it's actually a pretty easy thing to get. And we're going to get it as we do this part D here. Okay. We're going to get it as we do this part. So let's actually not worry about this. And we're going to talk about calculating the p-value. So now we will go into our stat test. We know that our null hypothesis is 0.7. He said that in the sample of 700 people, 71% own cats. So we actually have to find 71% of 700. So 700 times 0.71. So that's 497. Okay. So in here, 497 is the number of successes out of the 700. Then of course we want this to be a greater than. We hit OK. All right, so the p-value is very obvious to find, and it wants us to round this to 4 decimal places. So pretty easy for me. I can just copy and paste, and then we'll round it up to 9. So that should be correct. So I have that correct. The test statistic is very simple. Really, essentially, this is just a z-score. That's all it really is. This is the test statistic right here. How does it want this rounded? It wants 2 decimal places. That's typical for how we do z-scores. So this would be 0.558. It doesn't look like they rounded theirs, but it should be okay if I do that. And then we have to make our decision. What is our conclusion? So we compare this number here to alpha 0.005. So remember the saying, if the p-value is low, reject the null, the HO, right? And we said, well, how low? Well, it has to be lower than this number. Is this lower than 0.005? No. If it's not lower, we fail to reject, and that's why that's a fail to reject there. Make a conclusion. So we fail to reject the null hypothesis. Then what's the other option? So there is what we did not find evidence. There is not convincing, there's not sufficient evidence that the proportion of people who own cats is larger. So that's why we would pick that. So I could submit, and I got all my parts right. Okay. So that's as much as I want to go through in this lesson. On the next lesson, which should be for the 9th, since we have Eclipse Day on the 8th here, I will be going over how to do this for means, and then we'll pretty much already be done with this unit, which is great because we only have one more unit after this, and then we can start preparing for the challenge exam.